All right, so let's go ahead and continue learning about ionic compounds. This next part that we're going to learn about, these are called polyatomic ions. The word poly means many, and atomic means atom. So that means there's many atoms. And they're ions because they have either lost or gained electrons. If you take a look at this list here, this list is in your book. It's in the back of your booklet. It's on the very last, on the inside of the back of your booklet. So it is on the back part of the cover of your booklet. So go ahead and look at those. You will have this list. You'll always be given this list. And so let's go ahead and talk about what this list means. What this list is, these are groups of atoms here. And they are covalently bonded, and we'll talk about covalent bonds later, but they're covalently bonded and they have either gained or lost an electron. And so take a look at HCO3, that's hydrogen carbonate. That has lost, or that has gained an electron, that's why it's a 1 negative. And so notice how there's 1 hydrogen, 1 carbon, and 3 oxygens. Those are all bonded together, and the entire group as a whole has gained an electron. So let's go ahead and talk about this some more. So again, polyatomic ion, poly means many, atomic means atom, and if you take a look, the carbonate is CO3, 2 negative. The covalently bonded unit is CO3, there's 1 carbon and 3 oxygens, and the charge that it has is a 2 negative. Let's go and take a look at phosphate. Phosphate is right here. It's PO4, 3 negative. And so what that means is it's PO4 is the covalently bonded group. Phosphate is PO4. There's 4 oxygens and 1 phosphorus. And the charge that it has is a 3 negative. Now let's go ahead and take a look at hydroxide. Hydroxide is right here. You can see it's OH, 1 negative. Now what I will say is if you look here, notice how it just has a negative with no number. If it just has a negative 1 with no number, what that means is that it's 1 negative. So the covalently bonded group is OH, and the charge is 1 negative. All right, let's go ahead and do nitrite now. Nitrite, right here, NO2, and again it's a negative charge there, NO2 negative. And so the covalently bonded group is NO2, so nitrate is NO2, and because it's just a negative, that means it's a 1 negative. All right, so let's go ahead and work backwards here. So NO3 right here, if you take a look, it's NO3. It has a 1 negative charge, so we write 1 negative at the top there. And if we look at the list, we see that it's called nitrate. Okay, so we find NO3. Here is NO3, 1 negative. It's nitrate. All right, then we have SO4, 2 negative. Okay, so let's go ahead and find SO4, 2 negative. We'll look at our list. SO4, 2 negative is right here. And that is sulfate. Now, let's go ahead and make sure that, let's recognize that sometimes it ends in an 8, sometimes it ends in an ite. All right, then we have ClO3, that is a 1 negative. This is chlorate if you look on the chart. And then we have NH4 here. It's NH4. This is a 1 positive. Notice how most of them are negative, but this one happens to be positive. In fact, it's the only one that is positive that we will talk about, and this is ammonium. And so, again, the key here is that these are groups of atoms. They don't separate from each other. They are covalently bonded together, and they have either gained or lost electrons. All right, so let's go ahead and talk about how we can figure out the formulas here. So lithium, if you look at your periodic table, all of these again make it 1 plus, 2 plus, 3 plus, 3 negative, 2 negative, 1 negative, 0. Here's lithium, makes a 1 plus. So lithium is a 1 plus. Now acetate, here's what you need to recognize. If it ends in an 8 with a T or an ite, like this one, it's going to be on your polyatomic ion sheet. And so acetate is right here. Now there's two ways to write acetate, all right? So you can write them either way, it doesn't matter. Notice they're the same thing. The only difference is you either write O2 or you write OO. Exactly the same thing though. So I personally write C2H3O2, and notice how it's a 1 negative. If we take a look here, it's a 1 negative. And so if this is a 1 positive and this is a 1 negative, you only need one of each to balance it. All right, for this next one, if you take a look, we have magnesium. Magnesium makes a 2 plus. Sulfate, again, it's in an 8, so it's a polyatomic ion. So we look at our little list here. So here's sulfate right here. SO4, it is a 2 negative. And again, what we want to do is we want to balance the charges. We want to have equal amount of positive and negative. And so the way you have equal amount of positive and negatives, you have one of each, one magnesium and one sulfate. And the thing to remember is, again, sulfate is SO4. So you got to include that 4. All right, so let's talk about this next one. This next one's going to be, just going to have an additional little part to it, all right? So ammonium happens to be a polyatomic ion. There it is. It's NH4, 1 positive. And sulfur, if you take a look at your periodic table, here is sulfur. Sulfur is a 2 negative. So let's go ahead and add that there. So sulfur is a 2 negative. Now I'm going to go ahead and erase this because I already know what's going to happen. So it's NH4. It is a 1 positive. This is a 1 positive. This is a 2 negative. Again, we want to have equal amounts of charges. So 1 positive, 2 negative. How do we balance those charges? Well, we balance it by adding another ammonium. So we will need a total of 2 ammoniums to balance with the 1 sulfide. So notice how the charges are equal now. We have 2 positives and 2 negatives. So let's go ahead and show you how you write this. So when you're writing this, ammonium is NH4, so you do have to write NH4. But how do we show that we have 2 of them? The way that you show that is by putting the ammonium in parentheses. And on the outside of the parentheses, you put a 2 to show that we have 2 ammoniums. And then we have 1 sulfur. All right, so let's go ahead and do this next problem here. So we have aluminum. And if you take a look at the periodic table, aluminum makes a 3 positive. Now hydroxide is a polyatomic ion, so if you take a look here, here's hydroxide. And it's OH, 1 negative. And so I want you to sort of anticipate how many of each are we going to need to have a balanced, balanced charges. Well, if you take a look, we're going to need 3 hydroxides. So we need 3 hydroxides because each one is a 1 negative. And then the aluminum is a 3 positive. And so we have 1 aluminum. And again, hydroxide is OH, so we have to put OH. But how do we show we have 3 of them? We show we have 3 of them by putting it in parentheses and putting a 3 on the outside. Now, what I will say is, here, I'm going to do a mistake that a lot of people make. What they do is they just put a 3 here. And the reason why that's wrong is because that 3 is only being applied to the hydrogen. But the thing is we don't have 3 hydrogens, we have 3 oxygens and hydrogens. And so we need to put it in parentheses like this to show that we have 3 of them. All right, so we have magnesium, makes a 2 plus. Phosphate, PO4, 3 negative. And so how do we balance this one? This is probably the hardest one you'll have to do. Well, what you'll need to do is you'll need to have 3 magnesiums. Let's see how this works out. So we'll have 3 magnesiums. And then we're going to end up having 2 phosphates, because look what happens when we do that. Notice how we have a total of 6 negative right there. And then look how we have a total of 6 positive. And so the 6 positive balances with the 6 negative. So it's Mg3. So we have 3 magnesiums. Again, phosphate is PO4, so you need to include that 4. But the thing is you put it in parentheses and you put a 2 on the outside, because look, we have 2 phosphates. And so that's why we put a 2 on the outside of it. So again, the key thing here is that there's 2 phosphates, and phosphate is PO4, so you have to write that PO4. All right, this part in your booklets, what I want you to do is put a big X in it, because we will not be going through that part. So we will not be talking about transition metals, for the moment anyways. All right, so let's talk about how we name ionic compounds, and it's really, really easy. Notice how we have, these are binary ionic compounds. That means there's no polyatomic ion in there. There's only 2 elements, and it's really easy. All you do is you name the first element. So this is sodium, so you just say sodium. Then what you do is you name the second one. Except the ending of it changes to "ide." So instead of sodium chlorine, it becomes sodium chloride. And it's that simple. Name the first element, lithium. Then what you do is you name the second one, except you change the ending to "ide." So instead of lithium bromine, it's lithium bromide. This next one is barium. Name the first one, barium. Then we have fluorine. But instead of fluorine, we have fluoride. And it's that simple. So go ahead and pause the video, fill out the rest of them, and see if you can anticipate what the answer is going to be. And what you see here is, notice you just named the first element, and then you name the second element, except for you change the ending to "ide." So see, notice how it's pretty straightforward. So go ahead, pause the video, copy those down, and then we'll move on. All right, and now we're going to go ahead and talk about how we name compounds with polyatomic ions. So what I want to show you here before, notice how there's only 2 elements, all right? So 2 elements, I know there's 3 total atoms because there's 2 fluorines, but notice how there's only 2 elements. If there is more than 2 elements, like this, that means it has a polyatomic ion. So you need to find the polyatomic ion. Now what I'll say is, to name this, you will always name the regular element, the first element normal, all right? So this, we have lithium, all right? And then what we need to do is we need to find this polyatomic ion, which if we look at our polyatomic ion sheet, MnO4 is right here. It is permanganate. And the only thing you do is you just name it normal, permanganate. It's really easy. So it's lithium permanganate. I'm gonna run out of room here. Then this here, notice how there's only 2 elements, so that means it does not have a polyatomic ion. So it is lithium bromide. So again, we change the second part to "ide." So I'm gonna do a couple more here. So this is magnesium. And then instead of nitrogen, it's nitride. All right, so this has 2, this has 2, this one has 3. This right here, MnO4, if we take a look at our polyatomic ion sheet, MnO4 is ammonium. So we just name that normal. And then this last part, fluorine, we do name it fluoride. All right, this one here is K, which is potassium, so we name that normal. And then we have CrO4, which is a polyatomic ion. So again, if there's more than 2 elements, that means you have a polyatomic ion. And CrO4 is right here. It is chromate. and we just name that normal. So if it has so essentially, let's go ahead and review real quick. If it is binary, which means there's two elements, you name the first element, then you change the second one to "ide." If there is a polyatomic ion, though, what you do is the first one you'll name normal, and then the polyatomic ion you name like it is on the list. So if you look on the list, it's ClO2 is right here. It's chlorite, and again, you just name it like it is on the list. Straightforward, easy peasy. And that's it. So go ahead and come to class with questions. I hope you have a great day. Take care.